Hello, I'm Christine Mohammed and today I will be explaining the topic tripeptide. Tripeptides contains 3 amino acid molecules joined together with the elimination of water and the formation of 2 amide bonds. It contains a carboxyl group. It is formed by a condensation reaction, so water is lost. It has 2 peptide linkages which will give you a tripeptide, which is the peptide bond. 3 amino acids with 2 peptide linkage will give you a tripeptide. The importance of tripeptide. It transports glutathione in the small intestines. It aids in drug metabolism. The tripeptide thyrotropin releasing hormone L-pyroglutamyl, L-histidyl, L-prolinamide acts on its receptors in the thyrotrope and lactotrope cells to promote secretion of the thyroid stimulating hormone and prolactin. So in this diagram here, I have valine, phenylalanine, aspartic acid. I'm going to show you how these 3 structures join together to form tripeptide by peptide bonds. So let's look at valine. The structure of valine is CH. There's a CH3 bonded to it, a CH3 here. Then we have a carbon, NH2 here. We have a hydrogen here. Then we have a COOH. So we know that water is lost in this type of reaction. Then we have a phenylalanine. We have N. We have hydrogen bonded to it. We have another hydrogen here. We have a carbon, a CH2 here. And we have another carbon, a double bonded oxygen. And we have a next OH group here. In aspartic acid, we have N. We have a hydrogen bonded to it. Another hydrogen here. We have a carbon. We have a CH2 with another carbon bonded to it and a double bonded oxygen and a HO group. Then we have a carbon with a double bonded oxygen and an OH to the end. So for this peptide bond to occur, water must be lost through a condensation reaction. So we can see we have a OH here and a H here. So H2O is a water molecule. So water comes out for this peptide bond to occur. Water must be lost. And when that happens, the structure remains the same, but we get a carbon double bonded to an oxygen here. I have an N bonded to an hydrogen on the opposite side. And when we see that water is lost to form this peptide bond. Let's look at the phenylalanine and aspartic acid structure. So we already have valine and phenylalanine bonding here. So let's bond phenylalanine now to aspartic acid. Again, water must be lost to form this peptide bond because a tripeptide has 2 peptide bonds. We already formed one and now we are going to form the other one. This OH and H can form water here. H2O is water, so water is lost. And when water is lost, we get the structure remains the same, but we get a C double bonded to an oxygen here again, and on the opposite side we get an N bonded to an hydrogen. And then we have, it ends up with being 0 negative charge. And this entire structure, it forms a tripeptide valine phenylalanine aspartic acid at pH 7. And the net charge of this structure is -1. Now in this final structure, we can see that we have our 2 peptide bonds here, one peptide bond here, and the other peptide bond here. And we see our 3 molecules is bonded together, forming a tripeptide.